Hey guys, welcome to my channel. So in this video, we're gonna look at quicksort. So it's one of the finest sorting algorithms out there. It's utilized almost everywhere, and Java utilizes it as well. So you know it's a big deal, and you need to get your hands on it and try to implement it as soon as possible, right? So in this video, we're gonna run through how it works pretty briefly, and then we're gonna come back to this compiler and check, and then set it up and make it run, right? So let's go to the whiteboard and see how it works before we come back. Now this is a group of elements, so it's like apparently it's not sorted. I mean, obviously it's not sorted. So we have 5, 2, 7, 3, 6. Now the first step we'll do in any like quicksort step is to select a pivot element or a base element. We call it a pivot element, right? So what is a pivot element? It can be anything, right? It can be the first element, it can be the second element, it can be any element. For the sake of this video, we're going to select the last element as a pivot element. So why are we selecting a pivot element? So the reason why we select a pivot element is we try to put this element to its correct place. What we mean by that, right? So let's say we have 6 as a pivot element. So we know if everything that is going to appear before 6 is less than 6, and everything that is going to appear after 6 is like greater than 6, we know that 6 is in its right place, right? Then we know. So that's what we're trying to accomplish with the steps that we're going to do in our functions, right? So we're going to try to put this pivot element in its right place. How are we going to achieve that? So we'll have pointers for that, and when we code this thing up, we're going to see how we are dealing with the pointers and how we're like incrementing the other pointers accordingly. But briefly to summarize, or let's go through it. So we'll have 2 pointers, right? So we'll have let's call it a j pointer and an I pointer. So the j pointer is going to start from the lower element, the lower index, and the I pointer will be set to 1 less than the lower index. So 1 less than the lower index. Pretty self-explanatory. Now, what we're going to check? We're going to check if the array.j element is actually greater or less than the pivot element. So if the element is actually smaller than the pivot element, so in this case 5 is actually smaller than 6, what we're going to do is we're going to increment the I counter. So I is going to come here, and then we're going to swap the jth element with the ith element. So in this case nothing is going to happen because the j and the I element, they're at the same index and the element is the same, so nothing is going to happen. But it might happen. Well, we'll see when it actually takes place and the elements are different and how it swaps themselves, right? How they swap themselves. And so let's increment j again. So j is going to be outside, like in a for loop. It's going to be in a for loop, so j is going to keep on incrementing itself. Now j is going to come to 2, right? So 2 is less than 6. Now I is going to increment to 2, and j and the ith count, like the pointer, they're going to swap the elements, right? The respective elements. But this time again, they're the same. So it's a 2. So then nothing is going to happen. Now let's go to 7. Now 7 is different because 7 is actually greater than 6. So it doesn't satisfy that condition of the array.j element being lesser than the pivot element. So what's going to happen now? Nothing is going to happen actually. So it's just going to be like that. Now in the next iteration, j is going to move to 3. Now j is right here. 3 is less than 6, we know. Now, due to that, it's going to satisfy that condition that we have. Now I is going to increment, and now I and j are going to swap, the ith and jth element, respectively. This time, they're actually different. It's 7 and it's 3. So now we're going to have this. 3, 7 after swapping, 6. Sorry, I'm just going to get better. 6. And the rest of the elements, they're going to remain the same. So yeah, now we have this. By the way, j is done traversing the whole array, so it's going to traverse 1 less than the higher index, right? So it's going to traverse till here, so it's done traversing the whole array. Now, after we're done traversing the whole array, what we do is we basically put this pivot element, so this is the pivot element, we put this element in place of the I plus 1 element. So what is the I element? What was the last ith index. That was here, right? So that's 0, 1, 2, 3, 4. So the ith index was 2. So I plus 1 will be 3. So right at 3 index there is 7. So we're going to swap this pivot element with this index. Like whatever there is, like whatever element there is in this index, we're going to just swap it, right? So after we swap it, what are we going to have? We're going to have this 5, 2, 3, 6, and 7. And does it look kind of familiar? Like if you see, if you focus on it, 6 is actually in its right place now, because everything that is appearing before 6, as we talked about, is actually less than 6, and everything that appears after 6 is, even though it's one element, it's actually greater than 6. So 6 is actually in its right position now. Let me just write it. So 6 now, which is our pivot element, as it is at its right position. Now what we do is, now this is going to be inside a function, right? It's going to be inside a function, and that function, after doing all of this, after swapping the elements, at the end too, we're going to return an index. What is going to be that index? It's going to be the I plus 1 index that we just used to swap the pivot element with, right? So we're going to return that. Why we're doing this? So it can be utilized by our main function, which is going to take care of the recursive calls. So it can be utilized by those, so it can then divide the remaining elements into 2 parts and then call quicksort on them recursively again and again until they're sorted and we have a sorted array. So the same processes are going to be repeated by these like elements, and 7 is just 7, so it's not going to do anything. So yeah, then we'll have a sorted array. So that was me briefing. Actually, we kind of went a little deep into it, but yeah, that was how quicksort works. Now we're going to come back to our compiler and actually code it up. So let's have an array, unsorted array. Let's 5, 4, 3, 2, 1 to keep it simple. And we're going to have 2 functions, by the way. And we're going to have the first function, which is going to be the main function. It's not going to return anything, so static void. I'm going to call it quicksort, and it's going to take care of the recursive call. So it's going to be passed 3 arguments. So it's going to be the array itself, then the low index, and the higher index. Just going to call it high. And now we're going to check for one case. So as long as low is lesser than high, why we're doing this? To take care of the number of elements we have in the array that we're going to pass on recursively, right, again and again. So it makes sure that there are at least 2 elements in the array. So that's it. If not, then we're not going to do anything. If yes, then we're good to go. And now we're going to initialize a variable that is going to store the index that we're going to get from the partition function that we're going to code up next. So we're going to just show that. Let's call it part-t, because it's a short form for partition. I don't know. Just call it that. Then we're gonna, we didn't code this yet, so don't get confused. We're gonna call this function, and it's gonna, like as we talked about, it's gonna return as I plus 1, that index, and we're gonna store it right here. So it can be utilized by the quicksort recursive functions. We're gonna see. So it's gonna be passed on the same arguments as this function. Then we're gonna call quicksort on the remaining, the left and the right parts of the array. So let's do it. So it's going to have the array, and then let's do it for the right part of the array. So it's going to be low and partition -1. So it works. If you're familiar with binary search, it kind of works like that, So partitioning the whole thing, and then it's going to be part2 plus 1 and then high. So this is for the left part of the array, and this is for the right part of the array, right? So that's it for this function. This was pretty basic. And now we're going to take care of the main function, which is going to do most of the heavy lifting, right? So let's code up the partition function, that is this function. Right here, static, is going to be returning an integer, which is going to be the index, partition, and let's pass, it's going to have the same arguments as the above, and high, And first of all, as we talked, we're going to set a pivot element, right? So pivot equals array.high, which is the highest element, as we talked. For this tutorial, we're going to set the highest element as the pivot. And then we'll also initialize the ith pointer, which is going to be one less than the lower pointer, like lowest element, lower index. If you remember, we did this, so it was one less than it. Then we're gonna have the for loop. So we're gonna initialize j, and it's gonna start from the lower index, and it's gonna traverse until the higher index. So basic traversal, j++, and then it's gonna check for a condition. Which was the condition again? It was array.j must be less than pivot. If it is, then we're gonna increment I, and then we're gonna just swap the ith item with the jth item, right? So basic swapping again, array.I, and put array.j and array.I, then we just put the temp variable and array.j. So we just swapped it. And then when we're done traversing the loop, the whole array, what we do is we basically swap the pivot element, which is array.high, with i+1 element, as we saw, to put the pivot element at its right position at the end. So this step right here, right? So let's do it. Int temp equals array.i+1, array.i+1 is gonna be array.high, because remember we initialized the pivot as array.high in here, remember? And then array.high will just have the temp variable inside of it. And then at the end, what it does, it returns the i+1 index. So that's it. That's pretty much it for quicksort, and we can try to see if it works or not. Let's see. So let's call the pass an array. The lower index is going to be 0. The higher index is going to be this. Return length -1. Then we're going to just print the whole array, and I'm just going to use this method provided by Java. It's just toString method array, and let's see if it works or not. And we have this sorted now, so as you can see, it's sorted. Let's try it for some duplicate elements and negative elements too. Just put in 0, 99, and let's run the code, and as you can see, it works perfectly. So yeah, that was quicksort, and let's run through the code again. So we have two functions. Quicksort, the main function that is taking care of the recursive calls, and it's taking in the partition index, the index we're returning from here, and it's dividing the array into two parts again with the help of that partition index. And yeah, then it's recursively calling on them until and unless like they're sorted by themselves, and we just get the sorted array back. So that's what this function is doing. Now about this function, it's setting the pivot element as array.high as we talked, then it's setting up the ith pointer as one less than the lower index, then we're traversing through the whole array until the higher index. We're starting from the lower index and we're going to the higher index, and then we're checking for this condition that we talked about specifically, that the pivot, as long as the pivot element is higher than the jth element that we're traversing, I will increment and I is going to swap with the jth element, right? So that's what we're doing in here. Now at the end, we basically swap the i+1 element with the pivot element. So we do that in here, and then we return this back so it can be utilized by this function, and so on and so forth. It carries on until we have a sorted array back. So that was quicksort, guys, and if you found this helpful, please leave a like, leave a comment, and share this with your friends. And yeah, have a good day, and thank you for watching my video.